This is a really good example of an EOC problem. It says, new photo imaging techniques on computers allow artists to distort an image from its original shape. Figure 1 is a square image. Figure 2 is stretched 4 units wider and shrunk 4 units shorter than Figure 1. How many square units greater is the area of Figure 1 than the area of Figure 2? So there's a couple things that I want to look at in this problem. It's asking how many square units greater is the area. So we're looking at the area of Figure 1 and the area of Figure 2. I'm going to tell you a common misconception with this problem that I have talked to a couple students about. The idea is, oh, since we're taking this section and we're adding 4, then we're taking this section and we're subtracting 4, technically aren't the areas of the two the same? The answer would be yes if we're talking about the perimeter, but the areas are different. The formula for area is length times width or base times height. So the area of Figure 1, that's going to be x times x. I know it's kind of hard to read in the graphic here, but this is part of your review worksheet. So x times x gives me x squared. And the area of Figure 2 is x plus 4 times x minus 4. If you go ahead and multiply those two together by using the FOIL method or the box method that we've talked about, our final answer is going to be x squared minus 16. The reason why we don't have an x value is because we multiply the outsides to get negative 4x, then we multiply the insides to get 4x. Those add up to cancel out, so we only end up with x times x, which is x squared, and 4 times negative 4, which is negative 16. So the question is asking us, how many square units greater is the area of Figure 1 than the area of Figure 2? Well, when we're looking in the difference of areas, the key word is difference. Difference represents subtraction. So if I take the area of Figure 1, which is x squared, and I subtract the area of Figure 2, x squared minus 16, we distribute that negative, and we end up getting x squared minus x squared plus 16. That cancels out to get us 16. So our final answer is that the area of Figure 1 is 16 units bigger than the area of Figure 2. And here's one more way of looking at that. Area of Figure 2 is the same thing as the area of Figure 1, except here we're subtracting 16. So in order to get this to be the same as this, we have to add 16 to this. So the idea here is that this area is going to be 16 units bigger than this area because we're taking 16 away.